Welcome! This is MachinaOS, the first intent-driven operating layer. MachinaOS turns natural language goals into inspectable system actions. Now with the Visual Studio and full MCP interoperability, models reason, tools act, events remember, and humans approve. Here is the journey we will take through 22 sections in about 25 minutes. We start with what MachinaOS is, then tour every runtime surface. Studio gets 4 slides as the visibility story, and MCP gets 3 as the interoperability story. We close with recent shipments and the canonical definition. MachinaOS is no longer a prototype, it's a platform. The runtime has been solid since Sprint 24, evidenced by 2,221 tests. With 84 registered tools and 17 views, the challenge is now coherence, visibility, and usability at scale. Everything in the UI is reachable programmatically via 230+ API endpoints. MachinaOS enforces strict separation between 4 layers. Reasoning interprets intent. Planning compiles intent into deterministic steps bound to tools. Execution runs those tools, pausing for approval on high-risk operations. Finally, system effects record everything as structured events. This separation makes the system inspectable, replayable, and safe. The dashboard is the system core, providing visibility at a glance. It shows memory usage, LLM provider, agent fleet status, registered tool count, events, and pending approvals. The contextual feed provides a live event stream. This is the home screen for the platform. Neuralink is the conversational interface, where you type a natural language goal. MachinaOS normalizes it, the planner compiles it, and the executor runs it, all in one surface. The tool registry and session context provide real-time visibility into available tools and the operating context. The tool registry displays 84 active tools, categorized by risk level, low, medium, or high. Each tool has a typed contract, making behavior auditable. Memory and workspace are browsable, with persistent state managed across 5 auditable scopes, allowing you to read and edit the agent's memory. The Workflow Composer allows you to create reusable multi-step chains. We ship 15 built-in templates, such as full project audit. Chains are versioned, exportable as JSON, and can be scheduled with cron, interval triggers, or webhooks. They can be run directly or opened in Studio for visual editing and debugging. Studio is a visual node-based pipeline editor, closing the visibility gap between planning and execution. The 3-panel architecture features a palette, canvas, and properties panel. You can manipulate nodes via drag and drop or with a full keyboard kit. Execute a full chain or debug it step-by-step with live state overlays. Studio is not a generic diagram tool. It understands the semantics of MachinaOS chains. It recognizes conditional diamonds, parallel swim lanes, and animated edges to reflect execution reality. This makes it a powerful debugger for execution. Studio offers 2 execution modes: Execute, which streams results to a tray, and Debug, which steps through one step at a time. Visual overlays show live state: amber pulse for running, green for success, red for failure, and dimmed for skipped. Presenter mode is a focused, full-screen view for explaining a workflow. Avoid duplication by dragging existing chains onto the canvas as subchain nodes, marked by a rose border and chain badge. The runtime executor handles recursive execution up to depth 5 with cycle detection. This enables building complex workflows from simple, tested chains. Agent coordination manages the fleet, performance, monitoring, and inter-agent communications. The communication graph visualizes agents like the orchestrator, browser, and debugger, showing message flow. Edges are typed by communication type, and thickness indicates message volume. The task timeline provides the history of every executed plan, including chain runs and multi-agent negotiations, with status, step count, and timestamp. Clicking an entry expands to a per-step trail with inputs, outputs, and durations. This timeline is the system's audit log. The metrics view shows the system's heartbeat with planned success rate, average steps, duration, and total events. Tool performance bars highlight fast and reliable tools. The event inspector is a structured, filterable stream of typed events like tool status changes and approvals, all with full detail. Plans produce artifacts. Every chain that ends with report.generate produces a self-contained HTML artifact in /report/. This includes an executive summary, subchain results, security findings, and the full step trail. Everything is locally composed, branded, and saved with 0 data egress. we have 4 more surfaces. Explorer browses the workspace file system with syntax highlighted source. Process Monitor lists running processes and lets you stop them. Settings manage system identity and configurations. Security Center holds the secrets vault, audit log, and vulnerability scanner. The Model Context Protocol, or MCP, is the interoperability standard for connecting LLM systems to external tools. MachinaOS implements both as a client, consuming external MCP servers, and as a server, exposing its capabilities to external clients like Claude Desktop or Cursor. The Universal Connector orchestrates a single chain across end systems. Each step can be a native MachinaOS tool today, or a drop-in MCP server tomorrow, without changing the chain shape. This allows for native capabilities today and broad MCP interoperability tomorrow. We demonstrate cross-system sweep and live recall. The cross-system sweep chain probes 7 subsystems with 0 glue code. Live recall orchestrates 3 independent MCP vendors, including live HTTP fetch, reasoning, and knowledge graph write, all executed locally with 0 glue code. Over 4 sprints, there was no new runtime, just more surface area. The core architecture remained unchanged, while accessibility, visibility, and control from the UI significantly expanded across Studio, Workflow, Notebook, and scheduling features. MachinaOS is a local-first, intent-driven operating layer. Models reason, tools act, events remember, and humans approve. Use Studio for visibility and MCP for integration. This 2-pronged approach defines the platform's current capabilities.